All right, we're going to pick up with number 18 in this video. So here we're given three different functions, f of x, g of x, and j of x, and we are asked to find the following values or expressions and simplify if possible. So these go back actually kind of to Unit 2 from the fall, just a matter of substitution. So f of 2 would mean that inside of function f of x, everywhere I see an x, I'm going to replace it with 2. So that would be 2 squared, which will really be 4. F of z, that means everywhere I see an x, I'm going to replace it with a z. Well, that just becomes z squared. And this f of x plus h, that just means everywhere I see an x, I now want to see an x plus h squared. So you could leave this as x plus h squared. You also could write it out as x squared plus 2xh plus h squared if you want to do that distribution. Function g is the square root of negative 16x. So g of negative 4 will be the square root of negative 16 times negative 4, which is really the square root of 64, which will be 8. G of w will be the square root of negative 16 times w. Can't really do anything about that one. If you wanted to, I guess you could take out a 4i, but that seems like a little too much. G of w plus h is going to be the square root of negative 16 times w plus h. I would say you could leave that. Or if you wanted to, you could distribute into negative 16w plus negative 16h. For function j of 6 is going to say anywhere you see an x, replace it with 6. So 5 times 6 plus 2, which will be 32. This would be 5 times m plus 2. Can't really clean that up. 5m plus 2. And this one would then be 5 times m plus h plus 2, which you could leave as is. Or you could distribute and say 5m plus 5h plus 2. Either one. All right, simplify each expression. We have some factorials. So remember with factorials, you want to look at the one that's bigger in terms of a factorial. So that's going to be the bottom. And you're going to start breaking that down. So we still have 5 and 3 on the top. This then becomes 8 times 7 times 6 times 5. And I would continue that pattern. So I can cancel out my 5 factorials, which means I really have 3 times 2 times 1 in the top and 8 times 7 times 6 in the bottom. If you want to make your life easier without needing your calculator, you could notice that 3 times 2 is 6, and that'll cancel there. So we get 1 over 56, but you also could use your calculator and get to the same fraction. All right, same thing with these factorials. You want to think about starting with the bigger number. And so this is kind of confusing because there's a variable n, but if you think about taking any number and adding 1, that's going to be bigger than taking that number and subtracting 1. So we're going to start with the top. Bottom I'm going to leave alone as n minus 1 factorial. The top I'm going to start breaking down. So this would be n plus 1. Then I'm going to lower it by 1. So n plus 1 minus 1 becomes n. Now I'm at n and I need to lower it by 1. So now I'm at n minus 1. And that pattern would continue. So those are going to cancel. And I'm left with n squared plus n. You could also write it as n plus 1 times n would be an okay final answer. So again, concept of a factorial is that repeated multiplication of the index decreased by 1 each time. All right, given the following sequence, we've got a whole bunch of stuff we need to find. So looking at this, I've got negative 25, negative 35, negative 45, negative 55, negative 65. And so if I continue that pattern, it looks like I'm going to go with negative 75, negative 85, and negative 95. My pattern was that my next term, a sub n plus 1, was equal to the previous term lowered by 10 with the starting term of negative 25. So that's your recursive. If this initial value, then the next term is the previous minus 10. Then it says find the nth term of the equation for the sequence. So a sub n, this, remember, I'm just going to set up as n minus, and then I'm going to need my common difference, which was negative 10, and I need some sort of coordinate pair. So I could use negative 25, I could use 2, negative 35, I could use 3, negative 45, doesn't matter. So again, this could be 1 and negative 25, but I also could have written a sub n equals negative 35 plus n minus 2 times negative 10, because you're looking at point slope form. And so what you've identified is your slope is negative 10 because of this arithmetic sequence, and you need any point in your sequence, which could vary depending on the index. All right, find the sum of the first 40 terms of the previous sequence using a formula. Well, what I have is the sum of the first 40 terms, is going to be equal to n over 2, so 40 over 2, times a sub 1, which is negative 25, plus, and the last thing I need then is a sub n. Well, my n is 40, so I need to find a sub 40. So that'll be negative 25 plus 39, because 40 minus 1, minus 10. So that's going to be negative 25 minus 390, which should be negative 415. So again, this sum that I'm using is from my formulas of the finite sum of an arithmetic sequence. So I'm going to do 20, because that's 40 divided by 2, parentheses, negative 25 minus 415. And I'm going to end up with negative 800 and 8,800, negative 8,800 is the sum of the first 40 terms. Remember, we can't do an infinite sum with an arithmetic because you'd be repeatedly adding, and so your sum is going to continue to grow. We can only talk about a finite sum, and that finite sum starts with s sub n equals n over 40. This is a sub 1, and this is a sub n. So, using your formulas. All right, given this following sequence, we've got 400, 100, 25, 25 fourths. Find the next 3 terms. Well, it looks like I am dividing each time by 4. I could find that officially by taking 100, dividing it by 400 to find my common ratio, which is 1/4. So my next 3 terms are going to be 25 sixteenths, 25 64ths, and 25 256ths. So my a sub n plus 1, my next term in my sequence, is taking the previous term times 1/4, starting with 400. So again, this was my common ratio that I found. So then thinking about my formula for writing a sub n, again, I'm going to just set this up. I need something to the n minus, and what I need then is my ratio, which in this case was 1/4, and I need some sort of coordinate pair. So I'm going to choose that the first term in the sequence was 400. Now, I don't have to stick with that one. I could have said a sub n equals 100, and 1/4 is still my ratio, but now this is going to become n minus 2 because 100 was in the second spot, 400 had been in the first spot. So remember, you just need a point with that ratio. All right, find the infinite sum. I'm actually going to jump to part E real quick. Why is it possible to find this infinite sum? Well, remember, the infinite sum is possible if your R value is less than 1 or greater than negative 1. Another way of writing that is that the absolute value of R is less than 1. So in thinking about that, my R was 1/4, which is definitely less than 1. So that means I can use my finite sum. So my infinite sum is equal to my a sub 1 over 1 minus R. Well, a sub 1 for me was 400, and 1 minus my R was 1/4. So that's going to end up being 400 over 3/4, which will really be 1600 over 3 for my finite sum. Okay. Again, you can find the infinite sum because your absolute value of R is less than 1, or your ratio is a number less than 1. Otherwise, you would need to use the finite sum formula for a certain number of terms, because your terms would be getting bigger in the positive direction or bigger in the negative direction, and your sum would not actually be able to be found if R is greater than 1. All right, find the formula for the nth term of the arithmetic sequence with a sub 3 is 15 and a sub 9 is negative 9. Well, to start, I know that a sub n equals something, n minus something. I'm looking for my difference, and I'm looking for some coordinate point. So I'm going to say I know a sub 3 is 15, so I'm going to say 3 and 15. The last thing that I need is my slope. So I can find the slope between these 2 points by saying 15 minus negative 9 over 3 minus 9. This will add, so I get 24 over negative 6, which means that my difference is equal to negative 4. So there is my a sub n. Now again, there's some other ways you could write that. You could have decided to use a sub n equals, oh, there should be a plus sign in there. And we've got n minus, and I still need to find that my common difference is negative 4, but I could have used that the 9th term was negative 9, and that would have worked as well. If you want to clean that up, you could say that a sub n is equal to negative 9 minus 4n plus 36. So a sub n is negative 4n plus 27. The reason why that might be useful to you is because then you can tell that your slope right away is going to be negative 4, and then your y-intercept would be your 27. I just realized on the answer key it says negative 4n minus 27. That's incorrect. Make that a plus sign. All right, 23. Find the formula for the nth term of the geometric sequence with a sub 4 is equal to 5 and r is equal to 2. Well, a sub n for a geometric starts like this. I need my ratio, which they nicely gave to us, is 2. I need some coordinate point in my sequence, which the 4th term was 5. So that went pretty quickly. And now I need to find the a sub 16. So 5 times 2 to the 16 minus 4, which would be 5 times 2 to the 12th, which ends up being 20,480. Having a hard time reading these numbers this morning. So that, again, you can type in your calculator if you want to. You can also think about what 2 to the 12th is and then multiply it by 5. All right, so it says to identify the conic, write its equation in standard form, and find key features, then sketch. So I'm just going to start on this video by identifying the conic, and then I'll actually do the work in the next video. So when I look here, I have x squared and I have y squared, and these have different leading coefficients, but with addition, they are both positive. So this is going to be an ellipse. This one, I only have one term that's squared, so that's going to indicate a parabola. 26, I have a y squared and an x squared. They have different coefficients, and I have this negative sign, so this is going to be a hyperbola. And then this one, I have x squared and y squared. I've got matching coefficients, and both are positive, so this is going to end up being a circle. And again, I'll complete out the rest of the work for these problems in the next video.